Hello everyone, my name is Sebastian Solnica, and in this short video I will show you how you may use detours and withdll, which is a new tool in the wittracenet toolkit, to trace WinAPI calls. You may download withdll from the GitHub release page. And to make it more convenient for you, I also placed there the compiled versions of a few detours samples and that are great troubleshooting helpers. In case you haven't heard of detours, it's an open source library developed by Microsoft that allows you to hook or detour function calls in a process. We usually implement those hooks in a DLL that we later inject into a remote process, and withdll can help you to do that. So let me show you how you can use withdll. I already downloaded the executable and unzipped those detours zip files that you can see here. And one of them contains 32-bit versions of the DLLs. So you can see this 32 suffix, and the other one contains 64-bit versions. And we'll use both in this video. Additionally, we have various tracing libraries here. So those DLLs contain hooks to different WinAPI functions, and TraceAPI 32 or 64 DLL is the biggest one. So it contains the biggest amount of hooks, and that's actually a great DLL to use when we want to trace WinAPI calls in a remote process. So let's use this DLL with, for example, Windows version application. So the window that shows us the version of Windows that we are running. And the command line for withdll is requires a -d option, which is for providing a DLL path. In this case, we'll use the TraceAPI. Maybe the 64-bit. We'll start with this one first, and then we'll just type winver.exe. So that's the way how you can inject DLL into a newly started process. So let's run it. We see that the winver process started, and let's see if it has the TraceAPI DLL injected. We can easily do that in System Informer or Process Explorer. If we go to Modules page and look for the TraceAPI 64 DLL, we can see that it was loaded. So withdll worked, but of course we haven't yet collected any TraceAPI calls. So to collect them, let's open a new command prompt. This time we'll run scilogd, which is an application provided from the detours repository as well. And this is just a collector of the logs that are being sent by those trace DLLs. They are using a named pipe, and scilogd is just a listener on this named pipe. We can provide a file path here, then those logs will go to a file, but if we are only interested in seeing them, then we can simply use the standard output like I did. And to make to show you something else, this time we'll use the 32-bit version of the winver executable. And you might see that I left the suffix 64. It's not by mistake. I mean, I could switch to 32 and that would work, but it might be also convenient to, if you have those suffixes in the DLL names, then withdll detects the bitness of a remote process, and it will pick the right DLL when it finds that the started process is the 32-bit one. So let's see how it works. So we started winver. We can see that it was a bit slowed down a bit because there were many messages that were sent to scilogd, and we can see that those messages are here, and there are tons of them. Many of those in this case are window functions because that's a GUI application, but you can see that scilogd, or actually the trace DLL, prints the result of a function call and also its parameters. So it's a really great way to collect information about what's going on in a remote process. So let's stop scilogd and also the winver, and this time let's maybe inject a DLL into a process which is already running, and we will use Notepad for that. So that's the new Notepad. In a moment we'll get process ID, but this time we'll filter the output of the scilogd to only calls to a create file WinAPI function. So we'll pipe the output, and now we'll inject our DLL. We need to have the process ID. So let me use System Informer again. Let's bring focus on the Notepad executable. So the process ID is 14608. 14608. So instead of typing the path, we use the process ID, and now with DLL should inject the DLL into the remote process. So let's do that. Let's check if we have this DLL injected. Trace API, we can see that it's in Notepad, and let's try to save a file. I think I already had it. That was the test txt that I opened before, but let's double check. So it's also slowed down. We can see that there are many calls to the create file. So when Explorer opens this window, you can see how many things are happening in the background. That's also an interesting thing. Usually I use Procmon for that, but with Procmon we are logging events on a different layer, because Procmon provides a file system driver. So we are logging events from the kernel. Here we are in a user mode. We are hooking user mode functions. So if I type test2 txt and save it, you can see that this test2 txt appeared in our log, and we can see the handle that was returned from the create file w function, and we can analyze all the calls. Of course, here we had the filtered view, but we can have more filters in the pipe, or we can log to a text file and then analyze those events. That's one of the ways how we can trace WinAPI calls. And that's it for today. Thank you.